Hey guys, welcome to today's video lectures. So it's been long, and I guess you must be very missing my lectures. And today you're going to see my face because I forgot to put on my makeup today. I don't do it very well as usual, so please allow me to start today's lectures without showing my face. So today I'm going to finish the whole number 6 material, CAPM, Capital Asset Pricing Model. And as we discussed, so this model can be summarized in this single figure, security market line. So in the security market line, it can tell us the relationship between expected return and systematic risk, or in other words, betas. So in the x-axis, we have the betas, which is the measure for systematic risk. In the y-axis, we have the expected return for any financial assets. And if this financial asset has no systematic risk, for example, the government bond, usually, no matter how the business cycle change, the expected return is unaffected. So if this is the case, the expected return should be here. When the beta equals 0, the expected return for asset with 0 systematic rate should be RF. On the other hand, this portfolio is also important portfolio because this is the portfolio with the betas equaling to 1. So we know that market portfolio, by definition, its betas equals 1. So if there's an asset whose systematic risk is identical to market portfolio, then the expected return for this asset is equal to the expected return of market, or RM. And the difference between the market portfolio's expected return and risk-free rate is called market risk premium. Okay. And the line combining risk-free interest rate and market portfolio is called security market line. So if asset systematic rate is higher than the market portfolio's systematic rates, then investor will require higher expected return. But as we discussed, there's a lot of things we need to be careful when we interpret the conclusion in this security market line. First, this security market line only tell us the risk and expected return relationship when there's no mixed pricing. So, or in other words, if the price of any asset is correctly priced or is under its market equilibrium condition, then we can say that this asset's expected return and risks should lie on this red line, security market line. Okay, and this is number one thing. And if there's an asset, let's say its beta equals 2, then based on the capital market line, security market line, we can infer its expected return if this asset is correctly priced. So based on these figures, we can estimate the expected return for this asset. Let's say this is XA with a beta equals 2. So the expected return RA is higher than market portfolios expected return RM. So this asset expected return is higher than market portfolio's expected return because it has higher betas. And the risk premium for this financial asset A is just simply the difference between expected return of A and RF. So this is the risk premium for asset A. As you can see, the risk premium RA subject RF, this is the risk premium for A, is 2 times as large as that of the market risk premium. So market risk premium is market's expected return subject risk-free interest rate. So this is exactly the betas. So because 1 unit, the price of 1 unit of betas is market's risk premium, and because this asset A, the risk measure is 2, so the total risk premium is 2 times market's risk premium. Okay, so this is a quick summarize. And we also discuss about a kind of maybe confusing issue. So as I discussed in the previous discussion, the CAPM can tell us the expected return of any given financial asset if these securities is under market equilibrium condition, or in other words, when if there's no mispricing, then we can say that the expected return of any given financial asset should lie on this security market line. On the other hand, we know that in the financial market, sometimes mispricing can occur, can be underpricing, can be overpricing. And if we go back to this line, so if everything is under market equilibrium condition, there's no mispricing. So based on A's betas, we can get the expected return of A should be RA. If in the market, if mispricing happen, let's assume that in the market, if A's expected return is equal to RA slash. So if this is the case, so this means that A is underpriced. So the reason is, I think there are many other assets has the same level or better with A. Let's say both A and B, they have the same level of betas. So based on the security market line, we know that the expected return for A and B should be identical. So RA equals RB. So this is the expected return if there's no mispricing. On the other hand, if A can provide higher expected return, while B only can kind of offer the expected return equal to RA. So this means that even though A and B, they have the same level of risk in the current market price, A can provide higher expected return. So I think for every regional investor, I mean risk-averse investor, you should prefer to purchase A right now, because even though A and B, they have the same rates, however, A now provide higher expected return, which is I slash here is higher than B. So investor will sell B and buy A. If the A's demand was increased, then A's price will be increased. So this means that if we think backwards, the A's current price should be lower compared to its market equilibrium price. Okay. So this is kind of additional comment to what we have discussed in the class. So vice versa. So if A is lie below the security market line, so this means that in current market price, A's current price, it can only provide the expected return of I slash and slash. So in this case, this means A's current price is probably overpriced because we have discussed the equation here. So the expected return is calculated based on this equation. So denominator is the current price. So if the current price is too high, so holding the numerator constant, so this will lead to lower expected return for A. Finally, I would like to summarize number 4. And let me start with the conclusion. The beta of portfolio is the weighted average of all the beta of security included in the portfolio. Okay, so this is kind of, so you can choose some asset in your portfolio, and your portfolio's systematic risk depends on the characteristic of the asset included in your portfolio. To be more specifically, it depends on the beta of the asset included in the portfolio. If you include many security with low betas, then the total risk of your total portfolio will be reduced. So total risk means the total systematic risk. Let me use a simple example to justify. So based on this conclusion, we have 2 ways to calculate the expected return for a portfolio. Okay. Let's assume the investment weight for A is 60%, investment weight for B 40%. The covariance between A and market portfolio is 0.004. The covariance between B and market portfolio is 0.01. The variance of market portfolio is 0.005, and the expected return of market portfolio is 8%. So risk-free rate 3%. So this means that the market risk premium, hold on for a second, should be 5%. The market risk premium is the market expected return subject 3%. So the 5% is the market risk premium, or in other words, if asset has a beta equaling to 1, then the expected return is 5%. So please calculate the beta of the portfolio and then its expected return. So we have 2 methods to calculate expected return of the portfolio. First, we calculate the beta for A. So it's the beta equal to the covariance of asset I and market portfolio divided by market portfolio's variance. Okay, so for A, we just use covariance between A and market 0.04 divided by market variance. So A's beta is 0.8. So this means that A's beta is smaller than market's portfolio. So this is beta equals 1. So this is market portfolio. And A is something like into 0.8. So A has a lower beta compared to the market. So it's less risky compared to the market's movement. And similarly, we can calculate B. So B is the beta is 2, so which means that B has a higher systematic rates. It's 2. And so based on the betas, we can calculate the expected return for A, which is the risk-free interest rate plus the risk premium. So the risk premium of A depends on two factors. One is risk measure, beta 0.8, and the price of the beta. So the price of systematic rates, as we discussed, that 1 unit of beta equal to the market risk premium, which is 8%, subject 3% is 5%. So we calculate that the expected return for A 7%, expected return for B, based on the same formula, is 13%. And once we get expected return of A and B, we can easily get calculated expected return of your portfolio. It's just weight the average, right? You have 60%. So this is investment weight of A. So this is investment weight of B. And then you calculate weighted average, you get the expected return is 9.4%. So this is the way I think you can figure out by yourself. However, we can use the conclusion from a previous slide. So we can calculate the beta of the portfolio first, and then based on the CAPM, we can estimate the portfolio's expected return. So we can first calculate the portfolio beta. It's a weighted average. So based on the conclusion, the portfolio's betas equal to the weighted average of the beta included in of the asset included in the portfolio. So this is A, beta A, this is beta B, and this is investment weight of A, investment weight of B. And weighted average tell us that the portfolio's beta is 1.28. And we also discussed the CAPM. So security market line can tell us the expected return of any given financial asset. So this financial asset can be a single individual asset, can be a portfolio. So as long as we know the betas, we can get the expected return under the market equilibrium condition. So the portfolio expected return, so risk-free interest rate plus beta times the market risk premium. So NR, let's say it stands for market risk premium. And we get that it's also 9.4%. So this is an important conclusion. This tells us that when we try to create our own portfolio, we can try to include low betas asset into our portfolio. So in that case, we can reduce our systematic rates of the portfolio. And I just want to discuss, kind of re-explain about the why market portfolio betas equals 1. So again, so as we discussed, in order to calculate the market portfolio's variance, we just need to sum up all the sales. So we have annual stock, annual securities. So this is N by N matrix. So let's first consider the first column. So the first column tells us the covariance between stock 1 and all the other security included in the portfolio. So this is covariance between stock 1 and stock 1. So this is covariance between stock 1 and stock 2, covariance between stock 1 and stock 3, and covariance between stock 1 and stock N. So similarly, the second column tells us the uh, covariance between the x2 and x1, covariance between x2 and x2, covariance between x2 and x3, covariance between x2 and xn. So I would like you to consider what does each column mean. So for column 1, the whole column is kind of measuring the co-movement between xn1 and all the assets included in the market portfolio. So in other words, this is the measuring the covariance between first asset and markets, right? Because the market portfolio includes any asset. So if you sum up all the sale in column 1, so actually you can treat it as the covariance between XA and markets. Similarly, column 2 measures the covariance between x2 and market as well. So similarly, we can have column 3, column 4, and column n. So each column represents the covariance between x1 and markets, x2 and market, xn and the markets. And let's please record the calculation about the betas is covariance of I and covariance between market and the variance of the markets. The variance the market is you sum up all the column, all the cell. The numerator is the covariance between one asset I and market. In the case of first asset, so the beta for the first asset equal to the covariance of first asset and the markets divided by market variance. So actually beta 1 measures the contribution of the asset 1 to the total market portfolio's risk. So we want to know because the denominator is the sum of all the column. And we want to know the contribution of each column. So if column 1 or asset 1 has higher beta, or in other words, has higher systematic rates, so this means that asset 1 has higher beta because it contributes more to the total overall market portfolio's risks. Similarly, if column 2, the asset 2 has lower covariance with the markets, so this means that this asset reduces the market portfolio's risks. So it has lower beta, lower expected return. And if you sum up all the assets, okay, sum up all the column, then simply you adding all the betas, okay, and the market portfolio is kind of weighted average of the betas included in the portfolio. Then this will give you the conclusion that market portfolio's betas equals 1. And for final section, there's another separate video. Please kindly watch the video and do the assignment. And thank you so much.